To a new problem solving, we have a rather time varying magnetic field problem. And the problem is a thin weightless dielectric rod of length L. That should be this. Can rotate freely in a horizontal position like this. Around a vertical axis passing through its middle. Okay. The two small balls of mass m and charge q are fixed to the ends of the rod. I can see that. The entire system is placed between the cylindrical poles of an electromagnet that creates a uniform vertical magnetic field with induction B, not this thing. Okay. And the diameter of the poles is D less than L. That's also correct. And their axis coincides with the axis of rotation of the rod. That's also feels right. And the magnetic field is uniformly reduced to zero. So initial magnetic field was V naught and it is uniformly reduced to zero. So that's right. Find the angular velocity that the rod acquires when the magnetic field is switched off. Okay. At the final moment when the magnetic field is switched off. Assume that the field was only between the poles of the magnet. This is not the trouble. The real trouble is that we first need to find out why the rod will start rotating. The first question, why will the rod start rotating? Because I can see the magnetic field produced between the poles of the magnet like this. Just I'm trying to picture this magnetic field like this, like this. It's a cylindrical region and it keeps on decreasing. So it gives rise, it leads to the emergence of a vortex electric field, non-uniform electric field. Sorry, what is called, what is its name? The non-conservative magnetic field. Vortex electric field means non-conservative electric field. It leads, and this electric field is going to act on the charges Q, and it will accelerate them. So the rod will start rotating. That's right. So to solve the problem, first of all, we need to find out the induced EMF due to this time varying magnetic field. And we all know perhaps how to do it. We are going to use the law of electromagnetic induction that is called E equals minus d phi by dt. And that will be minus S, the area of the cylindrical region, the cross-sectional area of the cylindrical region in which this magnetic field is varying with respect to time but uniformly distributed. And this area is pi d square by 4 because d by 2 is the radius. S here is pi d square by 4. But we don't know dv by dt. But dB by dt is going to be constant here because the magnetic field decreases at a constant rate. That means dB by dt can be written as delta B by delta t. And if we assume that the whole process happens over time tau, tau, that means the magnetic field decreases from value B naught to 0 in time t equals 0 to time t equals tau. Then we can write here delta B by delta t as 0 minus V naught by tau. Tau minus 0 is tau, of course. And that is the slope. dB by dt is the slope. And t equals 0, its value was that means in general value of B, we can write B equals mx. That it is delta B by delta T mx plus C. And at t equals 0, B was B naught, so C was B naught. That means we have the expression for magnetic field as B naught minus B naught by tau T. And important thing we just needed this one. So why I'm focusing to find out the magnetic field. I got it this earlier, but old habits. So induced EMF we got is area minus and this minus, this minus and this minus is going to be cancelled out. So area is pi d square upon 4 divided by multiplied by dB by dt is minus sign gone, B naught by tau. So we have the result. Induced EMF equals pi d square B naught divided by 4 tau. Oh, this is one of our results we are looking for. So, and this cannot be solved. The problem cannot be solved because it was asking for angular velocity of the rod when the magnetic field was switched off. So we need to bring some kind of mechanics in here, and to bring the mechanics we need some kind of force. So here we got the electric field, and this vortex electric field can do work because it induces in circle and it will act on the both charges, and for one charge it will always act electric field like this, always. So for one revolution, the work done by electric field, the work done per unit charge is called the induced EMF. And work is here done by the vortex electric field, the non-conservative electric field. So work done can be, and this electric field is a constant. That means dW can be reduced to W by Q, and W work done per unit charge, and this work done is the force of the non-conservative electric field induced. So this will be force multiplied by not displacement and every point. So every point force and displacement are in same direction. So for one revolution, it can be written as 2 pi r, but r is 2r is L. So you can write here Ap multiplied by pi L divided by Q, and force per unit charge in the induced electric field. So this can also be written as E pi L, and we can find out E because our EMF, induced EMF, is something like pi d square B naught by 4 tau. So we can write here induced EMF equals pi d square B naught by 4 tau, and this will be equal to E pi L. So pi gets cancelled out, and we can get the value of this induced vortex non-conservative electric field as d square B naught by 4 tau L. This is the electric field we got. And system is symmetric. So to find the angular velocity of rotation of the rod, we can consider only one charge. And this charge is in vortex electric field is acted upon by the force QE along the tangent to the circle along which it moves. So in accordance with Newton's second law, this force leads to the appearance of tangential acceleration, which is equal to, tangential acceleration will be equal to force by mass, nothing else, and that will be QE by M, and that means it's going to be Q d square B naught by 4 M tau L. So acceleration is this. And during time t, the velocity gained by a charged particle can be written as initial velocity was zero, so a tau. And the velocity gained by a charged particle in time t can be written as simply as q ds square v naught by 4 ml. And angular velocity, we just only now we only need to find the angular velocity, and angular velocity is v by r, and r is l by 2. So and the result we get is q ds square v naught by 2 ml square, and that should be the answer. Thank you very much for